Hello everybody and welcome to assignment Z. We're talking about the first page of Z. It's on page 263. And here we're just talking about the triangle inequality theorem that says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So here we are going to determine for 1 through 6 whether the given measures of the lengths could be the sides of a triangle. We'll just write yes or no. Well, as long as any two sides are greater than the sum of the other side, it is. So let's think about here on this first one, 4 and 6. If we add that together, that gets 10. That is greater than 3. So that works out. 3 and 4. If we add that together, that is greater than 6. So that works. And then lastly 3 and 6. If we add that together, it is greater than 4. So number 1 would be yes. Now there is a little bit of a shortcut here. If you just focus on the last two numbers, the bottom two, the smallest two numbers, and add those together, that is the one telltale sign if the three sides will be a triangle. The reason is if we use the other two sides, of course they will add up to be greater than the third side. So real quick, we'll go through that shortcut here and we'll look at the bottom two numbers, 6 and 9, and if I add those up, well, they actually equal 15, and the theorem says it has to be greater than 15. So as we can see from number 2 here, since it's equals, no, that is not going to be the sides of a triangle. Okay, number 3, 8, 8, and 8. Any two of these added together will be greater than the third side. So yes, those three would be the sides of a triangle. We'll just do our quick test here. The lowest two, 2 plus 4, greater than 5. Yes, it works. This is the side of a triangle. 4, 8, and 16. 4 plus 8 is 12, not greater than 16. So that one's a no. 1.5 plus 2.5. That's going to be 4, and 4 is greater than 3, so yes. Number 6, those three sides are the sides of a triangle. Okay, now for 7, 8, 9, 10, you're to find the range for the measure of the third side given the measure of the two sides. So these are two sides of a triangle. We are going to run them through the test to see what are the range of values for that third side. Okay, so 1 plus 6, if I add those together, they have to be greater than x. The other combination, if I have 1 plus x, this unknown side, it has to be greater than 6. And the third possibility is 6 plus x. That has to be greater than 1. So I want to solve each of these inequalities to find the exact values. 1 plus 6, 7. Okay, 7 has to be greater than x, or you can think of it as x has to be less than 7. Solve for x here. X has to be greater than 5. And then over here on this last one, subtract 6 from both sides, x greater than negative 5. This, we don't have to worry about that third possibility due to the fact that you will never have a negative measurement for a side of a triangle. Okay, so if you look here, we have to stay less than 7 but greater than 5. We can write that as a compound inequality with our third side here, less than 7 but greater than 5. So we can write that as a compound. Now if you look at these two numbers, there's something really simple about them compared to the two they gave us. This bottom number, the lowest end of the side of the triangle, it is simply the difference between the two given. This upper end is the sum. So real easy, we can do that for the rest of them. 12 minus subtracted from 18 would give us 6, and then 12 plus 18 is 30. That's our range for our third side. Yes, it's just that easy. Down here for number 9, the difference between those is 4, and the sum of those is 7. Our triangle has to be somewhere between 4 and 7. And then lastly, 82 minus 8, 74. 82 plus 8, 90. Our triangle has to be between 74 and 90. Okay, now 11. Suppose you have three different positive numbers arranged from order from least to greatest. What's the single comparison will let you see if the numbers can be the lengths of the sides of a triangle? Mention that up above for 1 through 6. All you have to do is find the sum of the lowest two numbers.